last set of presenter is basically talking about a project related to Maryland Transit Administration. First, we're going to have Leo speak. Leo works for AECon, is a consultant with Maryland DOT's Maryland Transit Administration. And then we have Woon. She used to be with Maryland Transit and then made a wise decision to go to AAA Foundation for Traffic Safety. So let's hear from them, Leo and Woon.
Hello everyone. I'm gonna start presentation first, and then Leo will continue this presentation, and it will be back to me again. So as David introduced me, I used to work at the MTA before I joined in the AAA Foundation. So this presentation, it was the work that I have done with Leo when I was working in the MTA. This is a little bit different from what I saw in this visualization presentation. This is actually used the transit data, transit-related accident data, and what the MTA, as we experience the accident every day directly and indirectly, this big transit agency also experience many accidents every day, especially involved with their transit. So this is how we, the M.MTA, visualize, map, and use this large accident data set, and how to use to improve the actual safety performance. So I'm gonna start with a brief overview about the Maryland Transit Administration, and then why this MTA agency need this accident mapping system, and Leo will continue discuss about the system features and functionality with some demo, and it will be back to me again to discuss about the uses and effectiveness of this system. So Maryland Transit Administration under Maryland DOT is our 14th largest multimodal transit system agency in the U.S. based on the annual vehicle revenue hours. It has over 110 million passenger trips annually and more than 3,000 employees. M.MTA operates 6 different modes here. The first one is local bus, paratransit, which is mobility, and commuter bus, metro subway, and commuter rail, also called a MARC train, and the last one is a light rail. So due to this large scale of operation and coverage with over 700 buses and 38 light rail vehicles on the congested and mixed transit traffic area of the Baltimore City street, there are many accidents occurring everywhere. I mean, within the Baltimore region and annually. So to tackle this issue, the first step M.MTA took was in 2000 to want to know that they want to know that which location and which route it has the significant number of accidents. And to achieve this goal, in 2012, M.MTA first launched their accident mapping system to visualize the bus accident location. And since this system was only implemented using bus accident data, they want to enhance this system to include all type of accident data, including light rail and the metro. So they launched in 2016 another accident mapping system with various enhancements, and one of them is claim cost data. So since this is the MTA, those buses and other transit modes is public service. They carry a lot of passengers, and once those transit modes involved in any kind of accident, those passengers also have some claims. So the M.MTA has to handle those claim costs too. So the M.MTA want to also know that which location has higher claim rate, the frequency, and at which location M.MTA spend most money annually. And another feature I want to point out is the supervisor zone. So this system can also group the accident data by supervisor zone, and this tool is especially helpful for the street supervisor to allocate their limited resources on the higher frequency area. So in addition to those features, that also has other various features, and Leo will cover with some more details with demonstration. And I will back to discuss about the uses and effectiveness of this system.
So the accident mapping system itself, it's a web-based, intranet-based web mapping application that we have. It's just internal to the agency. Right now we have over 10 years of accident data in the system, and we have 6 months of claims cost data in there, and we're rapidly looking to increase that. The system's set up to display the data. We just need to get enough in to really start mapping the trends with that. Quick technical details. The data services behind the application for the accidents is generated using ArcGIS Server Esri products. The application itself is built on the Leaflet JavaScript library, and we use D3 for the charting, accident points, and the clustering. So this is what the system looks like. When the user comes in, they get a 3-month snapshot of the accidents on the map there in the middle. Across the top, we have relatively standard mapping system functionality, such as a location search, a base map switcher. We have the ability to pull in, to display bus routes on the screen. But really the heart of the application is the filter pane on the left-hand side there. That is where the user can go in and really define what data they want to see and tell their story of the accidents and incidents. So we're going to look at that a little closer. We can filter by mode. So we have different departments, light rail, bus, and metro, who all want to see their own incidents. Within bus, we have separate bus divisions or mobility providers. We can filter by that. We have date and time filtering. Also, we can filter by preventability, whether an accident is preventable or not, which is a key metric for the agency. We can filter by accident code. So if we just want to see sideswipe incidents, where are they happening with our buses? We just select those codes and you can pull that information out. We can filter by bus route. You see here I click the number 8 route is checked. We also have bus model year, supervisor zone, and then we have a keyword search. There's an accident description, a free text field that you could type in, say bicycle, bike, different spellings, and pull any accident report that had that information in there. So as just mentioned, we're looking at the number 8 route here. User makes that selection, clicks find accidents, and the accidents display on screen. So you can quite easily see visually where the number 8 route goes by the various accidents that have occurred along that path. On the left-hand side, you see the filter pane has been replaced by a list view of the accidents based upon that query. Starts with the accident location, with the location with the most accidents at the top, and then goes down and descend in order. So with this, if we want to look at, say, Green Mountain 22nd, that's the location with the most accidents. If you click on that list item, it'll zoom you to the accident location on the map. You want to find out more about the accident, you click on the actual accident point itself, and we have a pop-up that has a lot of summary information by accident code, which division the bus has come out of. A great tool that a lot of our users really like is being able to get to the accident reports themselves. So this data here is You see the list on the left-hand side. That's the list of all the accidents at that location. You click on each one of those and get the detailed accident description on here. We have charting functionality with 5 accidents. Maybe doesn't tell you very much. I've got a better example later on. We can see you know, which routes. Obviously, we just searched the number 8 for this one, but we can see the northbound. That accounted for 4 of the 5 accidents. Maybe that tells us something. And then we also have the bus model year we searched by. Up top, we have a dynamic link to Google Street View. So just within the application themselves, the user can just click on that button and see that, you know, this is Greenmount 22nd Street. They don't have to go out to a separate browser and pull it all up separately. It's right here. And this tool is really useful for our safety officers. You know, they can see the striping, the street furniture around the intersection. You can see the bus stop there. So this has saved a few field visits just being able to pull this up directly within the app. Another piece of functionality, kind of walking through the system, is in the top right is the clustering tool. This is the typical view of the accidents. Each point on the map represents one accident location based on your query. You click the clustering tool and it clusters the data by supervisor zone. And as Woon mentioned earlier, this has been useful to our street supervision group. They can see which zones are experiencing more accidents and really target their resources appropriately. A legend here on the right-hand side. The accidents are color-coded by mode, so it's yellow through red for bus, the blues for light rail, and the greens for metro. And then the intensity level of the color represents the number of accidents or safety incidents at that location. So try to keep the application itself lots of grays, blacks, whites, so neutral colors, and then the accidents, the operational data itself is actually colored to really pop out there. This is an example of light rail accidents, and as I said earlier, you can select by mode. If you're just looking at the light rail accidents, we have mode-specific data layers that can add context to the map, so helps our light rail department, you know, understand better what's happening at a location. You know, are there crossings there? Are there switch locations? We pull that in from some of our internal services, and then some of this data is available through the Maryland Data Clearinghouse IMAP. Here's an example of metro accident location. Works the same way as with bus. You click on the location, you get a pop-up. Couple of functionality areas to show here. One with the URL. This is we have the dynamic URL routing. So you've put in this query for metro, and you're at this specific location on the map. That is all reflected in the URL. So we can just a user can just copy that, send it to another person within the agency, just via email, and then when they click on that specific URL, it'll take them to this area of the map based on the query that they had. We have reporting tools, being able to just pull out a quick report based on the query, showing what query you made, the map, charts, and some summary data as a PDF. Another good way for us to share information. And lastly, I just want to show you an example of the charting tool with a lot more data in it. So this is number of accidents by month, by accident type. So we can really see track trends over time. We can pull this chart out as an SVG file, and we can, it's got a lot of flexibility. The drop downs, you can filter by day of the week, month, and accident type, route, a whole variety of different functions that you can get from that. So that's it. That's the conclusion of the functionality section. And it's just going to conclude the presentation by talking about a couple of use cases.
Yeah. So how M.MT used this system? This is one of the example. The M.MT safety department generate this poster, external hotspot poster on the regular basis, usually annually and quarterly, to inform and aware, especially for the bus operators through the bus division and training, that this is external hot location. So while you are operating this area, just pay extra caution. I want to share one of the real example for the effectiveness and uses of this system. Back in 2011 and 2012, there are 33 bus accidents reported at the one specific location, this Baltimore Fort McKinley Tunnel Toll Plaza. Toll plaza is usually all the traffic is slowed down to go through the toll booth, and this is a wide open area. So there's not many things you can make any trouble. But there's a 33 accident reported in two years. So safety officers was wondering what's going on here. So a technician was dispatched and examined, and they found out this particular toll lane, number 3, and if you can see here, this is a 2 steel I-beam. This is supporting the roof of this toll plaza, and because of this, these steels are sticking out. This particular lane, the clearance length is very narrow, more narrow than the other lane. So actually, the bus has only 9 inches on both sides to go past safely without hitting anything. So that was the trouble. So what safety officers did is they collected data and did the investigation and made a report and distribute those reports to the bus division and training department, and to inform especially the bus operator who is passing this area. This is the location usually make a lot of collision with a fixed object. So go slow down or try to avoid use this lane to reduce any possibility of the accident. So the result was in 2013 and 14, we had 13 accidents reported, and 15, 16, we got 10, and for this year, we got only 2 so far. So we have the excellent job to make some effectiveness. So another future plan for M.MT can do that. The CBD, Baltimore CBD area, especially the Howard Street, has the light rail alignment, and this area is really congested with the fixed traffic, a large volume of pedestrians and visitors and other vehicles. So there's a high significant number of crashes with light rail and other vehicles, and especially with the pedestrians. So we want to use this system to prioritize which location, which intersection has higher volume of the crashes, and what's the problem, and how we can resolve this issue. So this is our presentation, and if you have any questions.
Just 12:30. So
okay.
No questions. No, actually, if you do have any questions, please ask Leo and Woon about it. Very interesting. Thank you so much.
No problem.
Any questions?